In this video, we will learn construction of homogeneous equations.
We will see how to construct homogeneous equation from the given specific solution of the equation. In last chapter, we had learned how to find out solution of the linear differential equation f dy equal to 0. We know that auxiliary equation of this differential equation is fm equal to 0. Fm equal to 0 is the auxiliary equation and its roots are m equal to some numbers. Its roots are m, and from that we can construct solution. Now, if we observe that in that solution c e raised to ax appears, c e raised to ax appears in solution if a is root of auxiliary equation and d minus a is a factor of differential operator. We also know that c x e raised to ax appears in solution if a and a are roots of auxiliary equation and d minus a bracket square is a factor of differential operator. We shall see which term shows which factors and what are the roots of auxiliary equation in a tabular form. We shall write here term in solution, then roots of auxiliary equation, and factor of differential operator. These are important things for constructing the linear equation. We had seen that if e raised to ax, first term, e raised to ax appears, then roots are a, only one root, and d minus a is a factor. Second, we shall take x e raised to ax, then a and a are the factors, roots of the auxiliary equation, and d minus a bracket square is a factor. Similarly, if there is a term x square e raised to ax, then a are the roots and d minus a cube is a factor, and in similar fashion we shall write x cube e raised to x is nothing but d minus a raised to 4, x raised to n minus 1 e raised to x is nothing but d minus a raised to n minus, and so on. Fourth, e raised to ax cos bx and e raised to ax sin bx. These term appears in the solution if auxiliary equation has a root a plus ib and A minus IB. Both root occurs in conjugate pairs. And here the factors in differential operator is D minus A bracket square plus B square. This is the factor of differential operator. E raised to ax cos bx, e raised to ax sin bx. These terms appears if A plus IB and A minus IB are roots of the auxiliary equation, and D minus A bracket square plus B square is a factor of the differential equation. Now sin h of ax and cos h of ax hyperbolic functions are in the root if and only if d minus a, if and only d square minus a square is a factor of the differential operator, and a and minus a are the roots of the auxiliary equation. And only constant term appears in the solution only if roots of auxiliary equation are 0 and the factor is d. If we keep these things in mind, if we remember these things, then we can construct the differential equation from the solution of the equation. Now let us take problems. First, find homogeneous linear equation with real constant coefficients. That is satisfied by six plus 3x e raised to x minus cos x. Our problem is, we have to solve the problem, find homogeneous linear equation with real constant coefficients that is satisfied by y equal to 6 plus 3x e raised to x minus cos x. Here the term 6, solution contains the term 6, that is equal to C1 or constant term appears in solution. That means solution means 0 is root of auxiliary equation. Zero is the root of auxiliary equation, and d is factor of differential equation. Second, the term e raised to x appears if 1 is the root of auxiliary equation, the term x e raised to x appears if 1 is auxiliary, root of auxiliary equation repeated twice, and hence d minus 1 square is a factor of differential equation. Similarly, the term cos x appears in the solution if plus minus I is root of auxiliary equation and d minus 0 bracket square plus 1 is factor of differential equation. Therefore, differential equation is d minus 1 square and d square plus 1 y equal to 0.